Hi everybody, welcome to this session. So today I'm going to share with you 3 mental models you need to have if you are new to Go. At the end of the session, you will start looking at Golang from a completely different mindset, and the things will start making sense which haven't before. And most importantly, this will eventually help you understand and write better Go code. So here is how we are going to go about. First 45 minutes, I'll be explaining these mental models, and we are also going to do live code, which is a bit tricky, but we are going to do it anyway. Remaining 45 minutes, we'll be having an open discussion where you can ask your doubts and questions. So if you have any, please save that for this session, and I'll try to answer those to the best of my ability. So my name is Rakesh and I run this channel called Codersgyan, and we also run a platform called codersgyan.com where we create content about backend engineering, software development, and generative AI. So this is my handle. If you want to connect or send me a DM, you can do it here. Now let's get into it. Go is an extremely simple language. So for the context, Go was created in 2007 at Google. So it's Google's language. And if Google hasn't killed this language yet, this means there is something special about this language. So this language is so simple that it has only about 25 keywords. And if you compare those with C++ about 90 keywords and Java about 50 keywords. But Go has only 25 keywords. And because it has only 25 keywords, it has fewer features. And these fewer features are on purpose. For example, Go doesn't have this while loop. We actually use a for loop for that. Go doesn't have enums. We use constants for that. It doesn't have inheritance. Instead, we use composition. So this language has very few features, and we reuse those features for different things. And this fewer features means fewer decisions for the developer. See, in other languages, they have so many features in the language, so much syntax to remember and understand. So this is a bit overwhelming for the developers. But in Golang, we have very few features, only 25 keywords. It means it is very simple, and developer actually can focus on business logic. If we have fewer features, this means we need to think differently. Why so? Because if we have fewer features, then we need to use a different mental model to achieve same thing what we could achieve in different languages, but with fewer features. That's why we need to have these mental models, which I'm going to share with you. So we are going to see 3 things. First is errors. So if you see other languages, we use something called throw and catch. We use try catch blocks. So we throw an error and then we catch it, hopefully, and then we handle it. But in Go, we have something different, which is errors are values. Means these errors are ordinary values which you can assign to a variable or receive in a function or written from a function. This is something different. So if this is something different, then we need to have a different mindset to work with these errors, which I'll get to. But our next thing is, which we are going to see, is interfaces. Now interfaces, we use interfaces to achieve polymorphism. When we have one task to perform and we need different algorithms, multiple algorithms, and we want these algorithms to be swappable at runtime. That is where we use polymorphism. So to achieve this, in other languages, we declare interfaces at producer. Means whoever creating these types, they declare their interface before the hand. But in Golang, we have different thing. interfaces at the consumer. So whoever going to use that concrete type, the consumer will declare their own interfaces. And this is something different, and this took me a while to understand and digest. Okay, so in other languages we have different kind of ways to achieve concurrency. For example, in JavaScript we have something called async await. The IO operations are done concurrently, but since JavaScript is single-threaded language, eventually the execution happens on the same thread. In Java we have multi-threading where we can do things, but there is a very big difference, and that difference is, in other languages we usually use this thing called communicate by sharing data. It means you have a data, all the tasks you have created, they share this data, and that is called communicate by sharing data. And for that we use something called mutex and locks. But in Golang we have completely different thing called share data by communicating or by communication. What does that mean? It means in Go, if we create these kind of workers or multiple tasks, we share data between them using communication. We don't share any data, share common data. We just send that data, kind of sharing an ownership. So this is completely different mindset, and we'll see it in code as well. But these three things we are going to see in today's session. So let's start with first one. Errors are values. Now in other languages we do something called try, and then we have catch block here. Okay, this is pseudocode. So we do some logic here, then this logic might throw an error, and then we catch that error here and we handle that, and hopefully we catch that. Because if you see code bases, for example any TypeScript or Node.js code base, there you will see there is bigger controllers, and in those controllers we have multiple try catch blocks, and wherever we think that this part is going to throw an error, we just wrap it with try and catch. Or even worse, what we do is we wrap whole controller within one try catch block, and there we don't have any idea where what happened and what failed. So that is the mindset where we have this concept called throwing an error and then catching it. But in Go we don't have that. We don't throw an error in Go, because these errors are just values. We can just store these values in a variable, or you can receive that value in a function, or you can just return that value from a function. These are just simple values. We don't throw that. So you might be thinking, if we don't throw an error in Go, then how we handle those? So let me take you to my code editor and let me show you how we do it. So here is the repository I have prepared. So this is our errors folder, and I have put here a TypeScript file as well to compare, so we can compare what is happening, how we do it in TypeScript and how we do the same thing in Go. Okay, that will make more sense. So see what we have a function called store, and we receive this ID parameter type number, and we return a number. So we're storing the data, and we are just simulating an error here. So we are checking if ID is less than 1, then throw new error. This is how we throw an error in TypeScript, right? So we threw this error here, and if the ID is not less than 1, then we come here and we return that ID itself. Okay, this is the simple function, but it is more than enough to understand the problem. So how we use this function? we use like this. We call store, we pass 0, and if we pass 0, what it will say? It will go here and it will throw that error, and in order to catch that error, what we need to do? We need to wrap this call in try catch block, and here we catch that error. We do something with this error. This is how we do error handling in Node.js or in TypeScript, right? And the similar thing we do in other languages as well, Python, Java. We have similar thing. We have these try catch blocks. Now let me show you how we do this in Go. So we have a main.go file here, and this is our function. The same function, we receive an ID called ID, integer type, and here we just log storing the data. Same check here, ID is less than 1, but here you can see we are not throwing that error. What we are doing is we are creating a new error, which we do with this construct, and we are assigning that error to a variable. And this is possible because errors are values. We can do this, and from here we are returning that error. We are returning this error. If you are coming from TypeScript or JavaScript, this is new. We don't return errors, right? We throw errors. But in Go, we don't throw. We return errors. So we are returning this error parameter, and you can see we can return multiple values from a function in Go. So we are returning the integer, the ID itself, which is 0 because we have error here. We are returning that error. If everything goes well, then instead of error, we are returning nil. And the ID itself. Now, how we handle these errors? Here in main function, we call this store function, and we know that this store function is going to return an ID and error. Two things. So we need to do like this to receive two things. And then very first thing we do is we check if error is not equal to nil, because we said here, if everything goes well, then we are going to return nil. And that is same thing we are going to check, but opposite, error is not nil. It means we have an error. And if yes, then we are handling this error here, and we are returning from here. So we don't go here. We just return, we just exit our program. So this is the way how we handle an error in Go. Now, if you have seen a little bit Go code, you have seen these constructs everywhere. If you have a function, you will see almost 40 or 30% code, just this construct. Everywhere we are checking error not equal to nil, error not equal to nil. Why? Because that is how we handle errors in Go. How we handle? We don't wrap in try catch. We just return from a function that error, and the caller, this is the important part, the caller of that function handles those errors. So this is the store. Main function is a caller. So we handle these errors here. Now you might be thinking that, Rakesh, this isn't a repetitive code. Everywhere we are just going to repeat these lines, error not nil, error not nil, error not nil. It is very verbose. And yes, I agree that it is a repetitive code, but that is what the Go team has chosen, and that is how the design philosophy of Go works. The main idea behind this is to have visible error handling. What does that mean? In TypeScript, we have invisible error handling. See, if you see this function store, you have no idea that whether this function is going to throw an error or not. There is nothing. You cannot see this in function signature, right? It is invisible for you. That is why you need to go inside that function. You need to see whether it is throwing or not, and then you need to decide that okay, it is throwing, so we need these try catch blocks. But if you see Go's code, you don't need to go to look into store function at all. You can just hover over and you see the function signature. It is saying that this is returning an error. And this is the benefit of having this kind of code. The error handling is visible, and you explicitly receive that and explicitly handle that error. This is a good thing. You need to write more code, but yeah, this is for good. So now you might be thinking that sometimes we need to ignore error handling. Is that possible here? Yes, it is possible. You can, if you want to ignore this error, what you can do is you can just underscore. You can put this underscore here, and then you don't need to handle that error. Otherwise what would happen? If you don't do that, this program won't compile unless until you handle that error. This is also a good thing, right? You cannot just ignore errors in Go. You need to handle those. So there are use cases where we need to ignore. So what we do is we just put this underscore, then we don't need to handle. Now you might say, so what's the point if we can just ignore it? Like in TypeScript also we can ignore it. Even ESLint, we can just put that comment and everything we can ignore. But see, we are not just ignoring. In TypeScript, we could just remove that try catch block and everything we would ignore, right? But here, no. Here we are using underscore. So there is something visible to the programmer that we are ignoring something. Okay? It's not invisible, it is visible. So this is how we handle errors in Go, and we can do this because errors are just values which we return. This syntax we'll see very often in Golang. It is idiomatic syntax. So everywhere we return these errors, and the caller of that function handles those errors. Okay, so after errors, we have this second thing called interfaces. Now, if you are coming from object-oriented languages like Java or even TypeScript, you know how we use interfaces. And I'm talking about the interfaces where the behavior is involved, not just TypeScript interfaces where everywhere we put fields and their types. I'm talking about where we have methods on those interfaces. And we use these interfaces to implement polymorphism. So let's say we have this email send client. Let's say we have this send grid, or we also use resend. We have these two clients, and in our application we need to use both the clients, but there should be a feature, or they should be swappable. If we need that kind of functionality, we use polymorphism here, and we implement that polymorphism using interfaces. Okay, if this is not making sense, I'll show you the code now and everything will make sense to you. So interfaces in other languages and interfaces in Go are completely opposite. So interfaces in other languages, the implementer, means whoever implementing the concrete type, they declare that interface. Declare interface at producer. Producer means whoever making these concrete types. They declare their interface, and then they implement that interface. But in Golang, what happens? We don't declare interface in advance. Whenever we need to use these types, the consumer, whoever using that type, it declares their own small interfaces at consumer. So bigger difference is in other languages interfaces at producer, and in Golang interfaces at consumer. So let's go to my code editor and let's have a look how we do this in TypeScript and in Golang. So we have polymorphism here, this folder, and we have TypeScript. So let me open this app.ts file and let's see what we have. See, we have an interface called email service. Let's say we are in our application, we need to send emails. So we use different clients or providers. So for that, what we do is, if we want to have our architecture scalable, swappable, for that we do these interface things. So in advance, what we do, we declare this interface, and this interface has these methods. And then what we do, we declare a class and we use this special keyword called implements. We are implementing this email service, this interface, and as soon as we do that, we need to implement all the methods this interface has in order to satisfy that interface. Otherwise it will give us an error. See, red, it is saying that one method is missing, which is close. So this is how we do it. So after implementing this client, how do we use it? So we use it like this. Let's say we have welcome function. So now we are at consumer. Okay, here this is consumer part. Whoever using this type or interface, this is called consumer, and above was producer. Okay, this is producer. So we are here now, and this is how we use this. So what we do is, in welcome function, we receive this email service, and you can see we are putting this interface name here. We could do this as well, send grid client, the concrete implementation. We can do that and everything would work. There is no problem. Why we do interfaces here? We put interfaces here because we need to have this polymorphism here. We could pass here send grid client, or we could swap this with sender, right? Or maybe any other provider. And for that, we need to have the interface here. We are saying, give me anything which has the methods of these interfaces, like these methods, any type. If we make any type and we implement these methods and we write implements email service, then we can pass it here. Okay, so see what we are doing. We are declaring an interface at producer and not at consumer. Now I'll show you how it is done in Go. So here is main Go file, and see what we are doing here. What we have is, we have send grid client. We don't have interface yet. Okay, we don't do that at producer. This is producer part. We create the concrete type, which is send grid client, for example, and we put all these methods on that client. And in Golang we don't have classes, so we use struct, and this is how we attach the functions, these functions on that struct. This is called method receiver. By doing this, the strange syntax, we are basically saying that this method belongs to this struct. Okay, so now you can see that we have this send grid client and we have all the methods attached to that struct. Now at consumer, so this is the consumer part, we are going to use that. So this is consumer. What we do is, same, we have this welcome message, welcome function, and inside that we are receiving this sender interface. You can see this is how we make interfaces. So we have made this interface, and we are saying that this interface has only one method. Why we are saying that it has only one method? We actually have so many methods on concrete type, but in interface we are saying that we have only one method, and that is the point. Because we do that because in this welcome function we are using only that function. If we are using only that function, then why would we make an interface where we have so many functions? I'll show you where this makes sense. See, what happens is whenever we are swapping those concrete types, for example, this sendGrid client, we made this sendGrid client. Okay, I'll comment this, and we can pass this to the welcome function, and it receives because it has this sender interface, and sender says that if any type has this send method, it means that type is satisfying this interface. So this struct, we had this send method, exactly same signature. This means now sendGrid client has satisfied this sender interface. This is mind blowing. And you have noticed here that we don't have any implements keyword. We don't need that in Golang because these interfaces are implicit. We don't need to have like implements this interface. If any type has the method, this method, it will implicitly satisfy that interface. And that is why we are able to do this thing, consumer side implementation. Now you might think, what is the benefit of doing this, right? So I'll tell you what is the benefit. Let's say we are testing this welcome method. Okay. And in order to test this welcome method, right now we have this sendGrid client passed in, and this sendGrid client might be calling real network request. And in testing, we don't need to do that. We need to have something fake or mock implementation. We don't need to send emails while we are testing, right? Automated. I'm talking about automated test, unit test, for example. And in order to test this welcome function, we need to make something similar, fake sender, for example. So I have created another text struct here, and on that struct, I have attached this send method or function. And as I said, if any type has this method, it will automatically satisfy this interface. It means welcome can receive fake sender as well. See, if I comment this and I can just pass this one and it will work. Now, what is the benefit? Benefit is, imagine if this sender interface had those 5 methods, how we have in TypeScript, then to make this fake sender, I needed to implement all the methods here, right? But we are not doing this here. We are implementing only one method, and that was possible because this consumer is declaring their own interface with the methods what they need actually. Only one. This send, it is using send method. So this consumer made this small interface having that send method. It means we are saying here that give me anything which has this send method. We don't care. It should have this send method. Okay, so by doing this, we actually get this benefit that we don't need to implement all the methods. This is very helpful whenever you are testing Go code. So this was our second thing, that in other languages, the producer declares interfaces, but in Golang, the consumer declare their own small interfaces. This is the main idea, small. In Go code, you will often see these small interfaces everywhere wherever we are using some types. Okay, this was our second mental model you need to have. Our next one is concurrency, and this is very powerful in Golang. So concurrency means doing same things at the same time. Okay, at least we feel that it is happening at the same time, but it depends. If you have single thread in your machine, like you have a one core CPU, so you have one thread. So if you are doing concurrency here, you will feel that everything is happening at the same time, but behind the scene it is happening differently. Behind the scene it is doing something called context switching, and Golang is very good at this because Golang has something called goroutines. Goroutines are just lightweight threads which we use to create multiple parallel tasks in Golang. And these goroutines are extremely lightweight. They start from 2 KB and they can grow if needed. But these are very lightweight. So what you can do is you can spawn thousands of this. This is the power. Even if you have single thread here, you can actually spawn thousands of these workers, and everything is possible because Golang has this scheduler which manages behind the scene how it is going to do context switching and all. Okay, so on single thread you get these concurrency in Golang because of goroutines. So the concurrency is done differently in different languages. For example, if we take example of JavaScript word, which is JavaScript is a single thread language, we use something called async and await. We have promises, right? So this async await also does concurrency, but there is a difference. The difference is async and await do concurrency on IO. So you can call multiple third-party APIs at the same time. That is concurrency happening. That is IO operation happening, and that is handled by this async await and something called event loop. But eventually when we get the result from IO, we execute the final part on that same thread, that single thread. Okay, so in JavaScript it's kind of half concurrent, and then on single thread it is executed on single thread. So this is how it is done in JavaScript. We also have worker threads in Node.js where we actually can have this parallelism, but that code gets very complicated. In Java we do something different. We have multi-threading, we have green threads. If we have multiple these workers, what we do is if we want to communicate between them, how they do, we have this shared state, and then this worker can access that state and this worker can access that state, and they can manipulate that state, mutate that state, or get that state. And when we have this concurrent behavior, we need to protect this state from race conditions. Means at the same time, if both try to mutate this data will get corrupted. So we use something called mutexes or locks. We lock that, so at a time only one worker can mutate the data because it locks it, and after mutation it unlocks, then next worker can mutate that data. So this I call is communicate by sharing data concept. Sharing data. In Golang, we use something different, and that is what that is? That is share data by communicating. So let's say we have these two workers in goroutines actually, and if we want to share some data, let's say this data we want to share with this worker and this worker. So we don't make it global, or we don't do like this. What we do is we have something called channels in Go. So we use channels to communicate between two goroutines, and if we need to send this data to this worker just write that data on this channel, and data goes to other worker through this channel. So we are sharing data by communicating through channel. That's why we don't need logs or mutexes here. Even though Go has these features, logs, there are some use cases to use those, but we share data by communicating. And because of that, we don't need to protect any shared state. We just use these channels. This is a different mental model. Now, let me show you how we do this in code. So in our code, we have this concurrency folder here, and we have TypeScript code as well. So what we are going to say is we have this concurrency in TypeScript. Let's open this one, main, and we are using promise all here. So by doing promise all, what we do is effectively we are launching this function. How many times? 3 workers, because this array has 3 elements. So we are launching this worker function 3 times, and this is done concurrently because we are doing here promise. Okay, that is what promise does. And when all the workers return, we get this result, and we can just loop on that result, and we can do whatever we want with those results. So this looks like concurrency. Yes, it is concurrent, but if we are not doing any IO work here, this code, this line and this line will be executed on the same thread. Okay, it is not executed parallelly or concurrently. And this concurrency is handled by event loop. Event loop actually queues these workers on the thread, but that is the main thread, single thread. Okay, so this is simplest one. I'll show you another one. For example, we have this echo worker, or let me show this one. Okay, so this is true parallelism in Node.js, where we use these worker nodes and we provide which code we need to execute. So we are saying that echo worker.ts we need to execute. So this is the file, and here we are doing what we are doing. We are doing something. We are sleeping for now. Okay, in real world there could be some kind of CPU heavy work, but we are just simulating here by sleeping 300 milliseconds, and then we are doing this thing, parent port post message. So this is the way in Node.js how these multiple worker threads communicate. This is a bit similar to what I said about Go. They send message through a pipe or something called port here, but this is not cheap in Node.js. Okay, because every worker thread has its own JavaScript thing, JavaScript event loop. So it is not cheap. It needs resources. Golang is very cheap. I'll show you how. So this is how worker threads communicate using this parent port, and back in worker stream we receive that data using this on method, and we use that data. Okay, so this is true parallelism in Node.js. Okay, now let me show you how we do same thing in Go. So this is Go file, and I have created this worker function. So first thing you can notice here, that concurrency or worker is nothing but just a function. I create a function, do whatever I want in this function, and to communicate, I'm creating a channel here. Golang has this channel concept. We create a channel and we spawn these workers using what? Just this keyword, go. Go, and go does its work, and we get this concurrency thing. These workers are going to spawn concurrently and they will do their thing at the same time. Okay, so we are spawning 3 workers here. We are passing this ID, and then we are passing this channel to communicate. In our case, what this channel is doing is, we are passing this channel, we are reading the data back in our main function, because when you spawn these workers, they will be doing their things in different threads. We can say if we have multi-core system, they will be doing their things in different cores, or if you have single core, but they will do behind the scene that context switching. They need a way to send the data back to the main go routine. This main function is also a go routine, so they need to communicate back, and they do this using this channel. We read data like this and we use that data. See this code, and what we did in Node.js, we needed 2 files first of all, and then we needed to do all these things. In Golang, we do simply just go and a channel for synchronization or data communication. That's it. And in Golang, these workers or goroutines are so cheap that we can spawn thousands of these in milliseconds, and they consume very less resources. So this is how we do concurrency in Golang. We don't share the shared state and then mutate and then protect it. We don't do that in Golang. We have different mindset. What we do is we use channel and we share data by communicating. We send data through channels. Okay, so this is one mental model you need to have. So these are 3 mental models which I wanted to share with you. These are different in other languages, and in Go we do things differently. Okay, so thank you so much. Now let's do a Q&A. If you have any question, please ask and I'll try to answer those.
Wow, Rakesh, really phenomenal stuff, man. Thank you so much for taking your time to put together this really clear explanation. Go shifts a lot of the responsibility for clarity in the code. They shift it to the right. And I feel like a few of the changes that Go has versus TypeScript or other languages would actually make understanding code bases and debugging your code easier. I think that's probably why Google made these decisions. Would you agree with that?
Yes. See, whoever starting learning Golang, the very first thing they notice is Go is very verbose language, right? You need to write these er, not, nil everywhere. In single function, you will have these 4-5 times. So this is very verbose, but we trade with the visibility, right? So everything is visible. You actually know where and what going to throw, and every line you go, it works how you read. There is no hidden abstractions or nothing. Everything is visible, and that is the beauty, I think, Go gives us.
One thing I noticed that I was in the bathroom for a second. I don't know if you went over this, and I actually am not a huge programming nerd. I don't know if other languages do this, but I noticed that in the function declaration, when you're using the function keyword, you first have your arguments, and then after your arguments, you have what this function returns.
Yes.
Um, and I really like having that all on one line, so you don't have to like look later in the function. Oh, what are we actually returning here? Um, I like how that's all defined on that declaration.
Yeah. Yeah, this is very handy, and I think TypeScript also has this, and these editors gives us IntelliSense. If we hover, you instantly see that what that function is returning, right? But yes, this is very clear to me, and I can, not even this, we even don't need to go here and see what it is returning, or is it throwing an error or not. We can just come here, and here we clearly see that this function is going to return an error, so I need to handle that error. Everything is clear and visible. Yeah, so that helps a lot.
I have a question. Um, have you, because I've never tried, vibe coding in Golang, but obviously you get kind of mixed bag with, other programming languages. Have you tried vibe coding, and have you seen good results from some of the models that are out nowadays? Or
Hmm. Yeah, I have tried vibe coding, but I do it little differently. I actually use. I think I have shared. I had shared in our group that I use different kinds of skills. Uh, One of these is Grill Me by Matt.
oh, that's right, yeah.
Yeah, so that helps me a lot. I use Claude Code for most of my agentic coding, and whatever their latest model is, that I do small trick here. Whenever I'm planning the things, architecture, or when grilling is going on, I use the smartest model, and when it needs to implement the plan, we can use just other model which is cheaper or faster. So that one trick I do. And I have tried open code as well, the Kimi model, which is which is which is very good, but it's not up to the mark yet. How Claude, how this Sonnet or Opus works, but it works if you have great planning. If you do great grilling, then you can get those results from Kimi as well.
Yeah, sweet, thank you.
Yeah, welcome.
So same as other Jake. Sorry if you answer this. Also, I missed I missed the beginning, and then you had to restart, so this was perfect. On concurrency, you mentioned that you can just like spawn a bunch of threads. They're basically like, well, I don't think you said they're basically free, but you said they're really low cost. How is Go doing that? Do you know? Does it just kind of have a thread pool that it's running all the time that it sends stuff to? Um, I assume it can't just be actually spawning. I guess maybe it could be, but
No, how I understand this, um, there is no thread pool. By default, it actually uses all the threads you have in your system. You can actually tweak that if you want. You just pass parameters while running the program. But behind the scene, how it does, if you have single core CPU, then also you can have concurrency, because behind the scene, it uses context switching, right? If you have studied computer science, then we have a concept called context switching. We end user, we feel like it is happening at the same time, but behind the scene, CPU is switching the context very fast. So we feel like everything is happening at the same time. This Go does because Go has this Go routine scheduler, which does behind the scene. So it kind of, we are getting kind of virtual lightweight threads. Go routine, each Go routine is lightweight thread. So if you have single thread behind the scene, you can spawn thousands of these Go routines, and this scheduler manages everything behind the scene, all context switching. Yes. Did I answer
Okay.
your question?
Yeah, the ended specifically, yeah. Which is that it has its own internal scheduler that it's
Yes. Yes.
doing everything with. Yeah, that makes sense. Thank you.
Yeah. Welcome. Any other question?
Yeah. So let's see. JavaScript has Express, and it also has a bunch of different frameworks. Java has Spring Boot. Python has Django. What are the libraries and packages that people typically use to build a backend server using Go?
We don't need any framework in Golang. You can actually build a production ready server using just standard library. So Go standard library has everything you need, almost everything. I won't say it has everything, but almost everything. Server, router, it has everything. You can build a production system using just standard library. It wasn't like that before. We didn't had. If I let me show you that. So we are working on this one. Yeah. So let's say we have this. Okay. So this is the web server we have built, and it is built using this standard library package net HTTP. You don't have to install anything. And this is how we do. It will look similar to Express.js or Django, whatever we do. We do routing like this. Before Golang 122, we didn't had this one. We couldn't mention the HTTP methods, and that's where people used to reach for third-party routers. Like there are many. There are Jane, Go, Eco. There are many frameworks and libraries available. But after Go 122, 1.22 version, we got this. We could mention the HTTP methods, and we could get the parameters as well, query parameters. Before this, we had to parse it manually. So after that, we don't need that third party thing. Maybe if you want to do something very fast and you don't want to, if you want to have everything out of the box, then yes, you might choose that. But I personally always go with the standard library thing. But yes, there are many libraries and frameworks available in Go as well.
Very cool. Now, I'm sorry, you said that they added the HTTP path keywords here in Go version 122.
Yes.
When was that? Like, how recent was that? What year?
Um, I don't remember the year, but it was not so long.
I'm looking it up right now. Let's see what
Yeah.
Google said. Uh, February 6, 2024. So
Yeah. So
very recent.
it was very recent actually. Yes.
I love that because I try to avoid using a whole lot of third-party libraries, and there's two reasons for that. My initial reason is that I get to have more ownership over my code. I get to actually write it and understand what everything does. Because, man, I'm not going to go through and read your library. I'm not going to do it. I'm too lazy for that. I'm not going to actually read the library. I'm just going to import it, and then I'm going to hope that the documentation is right. And then the other thing that we've been seeing recently are these crazy supply chain attacks. And there's been a couple third-party open source projects that have been compromised lately. And so
Yes.
now people are like thinking twice before they just blindly import every library.
Yes. In Go, we are little bit safe. We are not safe anywhere, but um, by doing this, we actually reduce that risk. In Node.js or JavaScript, the only problem I see is we need to install package for everything, right? We need to what if you want to do lines of something, we have package for that, and many people reach for that. So yeah, standard library in Go, we have so many things that it is enough to build production ready applications.
And then I guess on the end of that topic, is there what's the system by which you would pull dependencies? Is it a traditional, like you just clone the Git repo and it's in the source, or is it more like what Rust does with Cargo, where it has its own thing?
Yeah, so Go Go's source code is stored on any Git service, for example, GitHub or GitLab. And how we do is we do like this: go get and the whatever your library path was. For example, this we don't need this. GitHub.com, Golang JWT. This is actually the exact path where the code is stored. Okay, so we just install that using this, and it creates actually this file here called go mod file, where we have all the dependencies stored here. It also has proxy tries there, and if we have that package in that cache, then we get it from here, or it can directly fetch from the Git. And we don't need any package manager for that because it is inbuilt. You can just do this go get and the URL. That's it.
Okay, that's really cool. And then I saw in the file that there's a bunch specified by version number, so I figure it can look at Git releases and whatnot.
Yes, you can mention it exactly which version also you need.
Nice.
Yeah.
Yeah, I like that.
Any other question?
Yeah, Rakesh, there's Tony's got a question in the chat if you want to.
Let's say hypothetically, I was creating a Kubernetes orchestration for monitoring a Kubernetes.
Yeah, so it seems like what he's asking is you have this Kubernetes orchestration that monitors sheep in agriculture technology sector, right? So he's wondering if lean go for formal verification. Yeah. So like if you had could you clarify this, Tony? Like when you say monitoring sheep, what do you mean? Like you're just watching, having the Kubernetes cluster monitoring, some sort of monitoring process. You're getting some real-time data or something.
Tony is there. The nutrient values in specific brands of feed and the outcome based on the algorithm being monitored. Okay, I think I'm not understanding this question, but I'll try to explain something what I'm getting. So we need to build orchestration for monitoring sheep. So there is a software, right? There will be a software. Would you recommend learn go for formal verification of feed nutrient breed values? Serious question. I would need to formally prove that some feed brands are. See, it doesn't matter what software is you're building. Go always, you can build it in Go. There is no problem. Why I say it? Only one problem I see with Golang is it is verbose. If you need speed, if you need to build project very quickly, then the JavaScript, TypeScript, Node.js ecosystem or Python will help a lot. In Go, we write a lot of code, but we get better performance, even better than Python or better than Node.js. Go is extremely fast language. So yes, you definitely build that system whatever you are trying to explain here. You can build it if you need extremely high performance, because Go is known for that, and if you have time because of verboseness. And if we are doing agentic coding, then I think this verboseness point cancels, because you don't write code by your hand, right? So yes, that's my answer.
Rakesh, I think that was a great answer to Tony's insane question. Tony is such a funny guy, man. I love him. He's a little bit crazy. Um, but here, I actually had to Google his question because I didn't understand it either. And so Tony's working with Lean 4 a lot, and Lean 4, I guess, is sort of a framework for proving mathematical theorems. It uses Haskell, and then there's a couple other proof assistants. And I think using this term lean go, which isn't a widely recognized term, I think he's talking about using Lean 4 to verify some of the functionalities of a mathematically complex Go program. But I wouldn't imagine that for doing something as simple as monitoring sheep, that would be necessary. But if you were doing some very intense AI or mathematics stuff, maybe Tony the Lean 4 wizard could work with you.
Yeah, if it it is about Lean Go, some kind of framework, then I'm not aware of that. But yes, if you want to do some serious mathematical operations which need CPU, then yes, Go will perform better than Node or Python, for sure.
Yeah, I
Yes.
believe that Go is one of the best performing languages. I mean, it's right up there with C, C++, Rust. If someone wants to build a incredibly high performance language, we actually have two people in this group that work with high frequency trading, and those types of industries would benefit from maybe some of the Go architecture.
Yeah, which is interesting. I mean, I was gonna ask, is there? So I know like Kubernetes like CLI
kubectl.
is yeah kubectl is
Mhm.
is Go, right? But for like HPC systems, it seems that it's all like C++ based, right? Um, so I'd be interested to see if there's any HPC systems like would that be a good use case? I don't
Mm.
know to use Go language.
Um, if it needs the actually performance, right? C level performance, for example, or Rust level performance, then yeah, it makes sense to use those kind of languages where we don't have garbage collection, right? Those languages are faster,
Okay.
C, Rust. But in Go, we also can run C programs, C files. That those extensions are available. We do this in Node as well. We can run C programs as well, and in Go also we can do that. So if you see how I think of this, in your software, whatever software you are building, there will be only one piece or one portion where you need actually performance, not all the software. Right. So what you can do is you can build your all the logic where you don't need that kind of performance, but only that one piece you can just write in C language, for example, and run through Go. So that is one use case I have seen many times people do. That can solve the problem. You get Go and you get performance as well for that critical part. This is how this AI libraries work in Python. Python is very slow, but it has libraries which uses C language behind the scene, and it is extremely fast, right? For data science and model training, they are used.
Yeah, that makes sense. Yeah, I learned more about Go. I mean, I've heard about Golang before, but I've learned, I think, more about it than I probably have in all of school. So thank you for presenting today.
Yeah,
I have
it's
to
my
look
pleasure.
into this a little more. Cool.
Yeah.
Yeah, thanks, Rakesh. This was awesome.
Yeah, it's my pleasure, and I was very excited. And thank you so much. We can do more sessions like this in future about Go, some other stuff which is very interesting in Go. So do let me know.
Absolutely. All right.
All right,
Stop
then.
the